Hi everyone, today I would like to talk about WebAssembly and Kubernetes. Two exciting topics that with spin operator finally can come together. So today we will learn basics of WebAssembly. We will build a WASM app using a spin framework. We will learn about spin operator and how to set it up on Kubernetes. Finally, we are going to take the spin app we have built and we are going to deploy it on Kubernetes and see it running. There are no technical prerequisites for this demo. If you want to do this on your own, the link to the interactive workshop will be in the video description. Just a browser is needed and a GitHub account. It would be nice if you're familiar with HTTP API and have some basic familiarity of HTTP servers. And of course, some Kubernetes knowledge helps. But don't worry, I'll explain as we go. So first, a really brief intro to WebAssembly. This is not meant to be a comprehensive introduction, just to get us situated within the demo. So WebAssembly is a low-level, compact binary format. It's kind of like an assembler, but for a browser. So at the beginning in 2015, all major browser vendors get together and started working on the specification, creating something which is called the Bytecode Alliance. And now in 2019, it is currently a standard supported by all major browsers. So in a nutshell, what it can do, it can take many programs in C, C++, Rust, and so on. There's a list out there what programs are supported. And if those programs can compile to WASM, then they can run in web browser. So that's the gist. So now why are we talking about WASM in context of web browser? Simply because the properties that WASM has, meaning being very portable, small, and efficient, being extremely well isolated and sandboxed, are actually the same properties that are very important for cloud-native workloads. So some companies started looking at, hey, how can we take WebAssembly and kind of apply it to the cloud-native? So this was also a challenge because WebAssembly in and of its own cannot access any system resources. Similarly, like web browser JavaScript code, it's fully sandboxed. So there has to be additional specifications developed, like WebAssembly system interface and so on to make it work. But at the end of the day, now we can use WebAssembly to run actual workloads like HTTP web server. I encourage you to go through those links here in sources. Definitely worthwhile to getting more familiar with WASM because I think it's going to be more and more prevalent in the ecosystem. So let's create a WebAssembly application. Before we do this, we need some form of framework. Like in every language, you have some kind of framework that helps you build applications, test them, and so on. For WebAssembly, one of such frameworks is Spin. That's a framework developed by company Fermion. And what it does is essentially it's a developer-friendly way of helping you instantiate, bootstrap, and deploy a WebAssembly binary. So let's install the Spin CLI. We're going to move it to the bin path in our user path, and we are ready. Let's check the version 2.6.0 at the moment of the recording. That's it. That's all it's needed. Really quick installation. And now we can actually start creating our WebAssembly app. So first, we are going to update all the templates that are available in the Spin CLI to make sure that we have newest versions. If you know applications like Yeoman or similar, that's kind of the similar idea. You have various templates that essentially CLI integrates with and helps you create them. So we have here quite a few of those. Most of them are HTTP servers. We are going to use HTTP Rust just as an example, but you can create C, Go, PHP, and so on. Because we chose Rust, we have to actually add a compilation target for WASM32. So we're going to do this right now with the Rust app, Rust tooling. And now we can create a new spin up. Remember, we are really creating an HTTP server that you probably know. We just kind of doing a little bit on top to add some spin libraries, and we are compiling it to WebAssembly rather than to standard binary. So let's create. We have a very simple Rust folder structure. Now we can use the spin build command. I'm going to trigger it because it takes a while with Rust, and then we will take this time and see what kind of files we have in our folder. So since this is a hello Rust, that's, if you know Rust, then that's going to be super easy. But we have the src and a single librs file that is essentially a normal HTTP server. Even if you don't know Rust, that should sound familiar. Something that returns status 200, adds a header of text plain content type, and returns the text hello fermion. This is taken from the example page there. So very simple web server, nothing to do with WebAssembly per se, just normal web server. What makes it WebAssembly is this little spin tunnel, which is a configuration that Spin framework uses to tell the underlying toolchain of a programming language what target should we compile to. And here we have our component hello rust.build. We have cargo build, and we are targeting the WASM32 WASI. So whenever we are going to run spin build, this command will be run under the hood and we'll end up with a WASM binary. So far, so good. Let's go back to our terminal. We should be done. Yes, cargo have built our application and we have a WASM binary. Now, let's see if we can run it. So I'm going to do spin up, which is an equivalent of just running a simple HTTP server. And this behaves as you would have expected. It just creates a server, and that's about it. I'm going to copy this one, go to the other tab, and curl, and there we go, hello fermion. Everything works as expected, nothing magical right now. So what we've done, we've created a simple WebAssembly web server, sprinkling just a little bit of spin specific libraries. Otherwise, it's just a regular plain old HTTP server. So now we're transitioning to the spin operator. So spin operator is part of the spin cube project, which is a project that brings the WebAssembly to Kubernetes. And the way it does it is explained on this little graphic here. So spin operator is just your regular Kubernetes operator. Runs in a cluster, watches for custom resources. In this case, kind is spin up. We'll see it later. Once it gets this, it does stuff. So spin operator is going to create various Kubernetes resources and execute a workload that is WebAssembly. So how is it possible? This little guy, container d shim spin, is a helper process that actually translates between the WASM runtime and container D. Because as you know, container D runs regular binaries that are inside containers. In this case, we can actually execute a WebAssembly process inside of Kubernetes as if it would have been a container. So this is really good, mostly because we are really bringing all the Kubernetes resource model, ecosystem, familiar commands, and everything around it. This stays, and we're just bringing the WebAssembly part thanks to the operator and just working with it as we would have normally worked with any other Kubernetes resource, which is really powerful because it means that we don't need to learn anything new. Everything works out of the box, and we can execute WebAssembly based binary inside of the pod as we would normally execute a regular pod. Again, I'm not going to go super deep into it, but definitely encourage you to read about it more. The links will be later in different slides, but that's just a really quick introduction to get us started. So now let's go ahead and deploy the spin operator. As a first prerequisite, we need to deploy certificate manager, cert manager. That's just required for spin operator to create certificates between various pods. Then we have k-wasm operator, that is a dependency for our spin operator. And we have to bring on board a few CRDs for spin operator CRDs, runtime class, and shim executor. So I would imagine that this installation process will evolve and it's going to be much more compact and easier. But for now, we have to wrangle a little bit more commands in YAML to get it running. And finally, we are ready to install spin operator using Helm. So while this works, I'm going to open Octant. If you're not familiar with Octant, this is a project from VMware. It's unfortunately discontinued, but it's just a cluster viewer. It's a nice way to see what's happening on the cluster. So let's swap namespace to the spin operator namespace. And here we can see that we have deployment, we have one replica, pod, and other resources that our spin operator needs to run. So that's great. I want to show you one more thing. So we talked about custom resources. So we have custom resource definition that we just deployed earlier using the kubectl CRDs, this guy here. And those CRDs, let me make it a little bit longer here. For example, we have spin up custom resource definition. So that's how we defined what kind of custom resources we are expecting. And here you can see we have this little kind spin up. Otherwise, this is just a regular custom resource definition. If you're not familiar with them, those are just OpenAPI schemas essentially describing what resources can be applied to cluster so that operators and controllers can do something with them. So we already have those things. They are all installed and ready for us to do something. So now we are going to distribute our package inside Kubernetes. So if you're starting to think that it feels familiar, it does. It's very similar to Docker. So spin, registry, push, build, those commands are definitely following a Docker API. And this is a really good mental model to have when you work with this type of technology for spin. It's just really like working with Docker. We are doing something different here though. Instead of pushing to Docker registry, we are using TTL-SH, which is a really cool service that enables you to create anonymous and ephemeral Docker images that are time-bound. So in this case, this guy is going to last only 1 hour, so we don't overload the service. So let's hit it. Once we execute this, the spin will build our HTTP server, which we've seen earlier, our Rust server, will build it again and will push it to TTL-SH under this app prefix and hello Rust name. All right, we are ready to create our Kubernetes custom resource. We just need to install a kube plugin to our spin CLI. So now we have support for more commands, and we can use spin kube scaffold from our image and output it to spin up YAML. Remember, this image is an OCI compliant artifact. We can upload it into any registry that supports those. So this is really portable and again, integrates very well with the existing ecosystem. So let's give it a go. Okay, we have our spin up kind, and you can see here the name with the prefix to differentiate it and avoid name collisions. We have an image and importantly, an executor, which is a field that tells the operator which containerd shim to use to run it. And we are also specifying 2 replicas. Okay, so let's apply it and let's see what happened on the cluster. So we're going to go back quickly to the overview and we'll swap to default namespace. And if everything is okay, we actually should see some pods. And there we go. So we have deployment with our name, 2 replicas, 2 pods as we specified, and also a service, a config map, service account, and so on. So as you can see, those are just plain old regular Kubernetes resources. And nothing new happened really. The only difference is that the pods are actually using the containerd shim that enables us to execute WASM instead of a regular binary. Otherwise, we can click into pods and do things that you would typically expect. So we can just see what's happening here in the pod. We can see this runtime configuration. We can check events. Everything works as you would imagine. All right, if it works, then let's prove it. And let's actually run kubectl port forward to see if our app is accessible. So we are port forwarding it to local port 8085. Let's check it out. All right, I think we are lucky. We have output from the web page that's running on the cluster, and we just port forwarded it. We could, of course, use a service and so on. I just wanted to make it faster. Let me do one little experiment. It's not something I thought about earlier, but maybe I can show you something out of the box. This might not work, by the way, but I'll record it anyway. So we go to our manifest, spin up YAML, and let's change replicas to, let's say, 50. This machine, this VM that I'm working on, has 4 GB RAM and very little CPU. It wouldn't handle 50 normal pods. That would be really hard. It would struggle. But our WASM binary, that's one of the benefits of using it in Kubernetes, we can bin pack much more into the same infrastructure because our binary is really small. It's something below 20 megabytes. So let's see if it works. Let's save it. And we are going to apply the file one more time. Let's go back to Octant. And if we go here, we can see we have 50 pods registered, and this little green bar is going to start changing or expanding as the pods are coming online and as the pods are being triggered. So if I'm right, then this should start moving relatively soon, and we should start seeing the pods being, the deployment being scaled up to 50 replicas. Again, if it would be a traditional, regular deployment, this would probably wouldn't work on this machine at all, or it would take a really long time. We can starting to see the green bar start slowly moving. Now it should go a little faster as more pods are coming online. And there we go, more and more pods are coming online. If we swap to namespace overview, we can see that most of them are up and running. And that means that our app also, of course, works. So we've seen one benefit of using WASM in action. We were able to take the replicas and on a really low-end device, scale them to a pretty high number, which means that, WASM is something that is potentially usable on edge or on low-end devices. All right, great. We went through a lot. Let's sum it up real quick. So we started by learning about WebAssembly. We had a really brief introduction to what it is and why is it useful in a cloud-native space. We used Spin CLI to create our WASM microservice. Again, it's just a regular, plain old HTTP server, just wrapped with some Spin CLI magic and compiled into WASM binary. We have built this application and we used Spin to deploy it to our cluster, push it to registry, and we use Spin operator to actually run it for us. We also have seen how easy it is to scale the application to multiple replicas, also on a low-end device. So the key takeaway for me are the WebAssembly is really powerful, and bringing it to the cloud-native space gives us one more tool in a tool belt. It's obviously is not going to replace anything. That's not how technology works. We thankfully still have VMs and Docker containers, but having this another workload that can be used in certain circumstances is just really powerful in our arsenal. Spin as a framework simplifies the process. I really like the fact that there's a scaffold command that exists. I believe more command line tools should provide it so that people don't have to fiddle around copy pasting YAML. And we were able to relatively easily bootstrap our app, so that's definitely important. And we've seen how extensible Kubernetes is. I think, if anything, This demo shows that, well, Kubernetes can do almost anything. If we take the operator pattern and extend it with a different runtime, in this case, we can use WASM, and in future, who knows, maybe other runtimes as well. I've linked here quite a few resources. The spin is from the company called Fermion. I am not sponsored by them or anything. I just really like the product. I thought I'll include it here in this demo. So you can read those docs and join. And if you like this type of content, definitely give it a like, subscribe to my channel. I have also blogs and other stuff also coming in the pipeline. If you like the video, if you're curious about something, drop a comment. I'm really interested in knowing whether you're already using WASM in your cluster, or you see some use cases that you've been inspired by watching the demo. The link to this demo will be in the video description, so you can go through it yourself, click exactly like I did, and use maybe this video to help you guide through the whole process. All right, thank you so much for sticking till the end, and see you in the next video.